Okay, so we've got, of course, our progress. We didn't talk about that. That's, of course, what we're all here for. But you can see we're dealing with confidence intervals today. Nothing secret about it. We're going to kind of be talking about confidence intervals a full way through. Today, more on a conceptual level. We're going to be doing a little bit of calculations, but that's really going to be saved for tomorrow, where we're going to be going through the full process for calculating a confidence interval. It's combining stuff that you're already aware of. So I have made that point many times, but basically the second semester is a lot of bringing up concepts that we should already have a pretty good foundation with. Okay, but going through a few concepts today. But first, look at the progress we've made, guys. We started at Lee's Ferry metaphorically, and look at all this fun, statistical fun that we've had the way down the canyon. And look, we were at Ellis Chasm after the last test, but now with the most recent one, we made it to Deer Creek Falls. Isn't that exciting? Yes, yes, it is.
I have a question.
Yes.
How do you get back to your car?
I mean, in reality, I believe you get shuttled.
Oh, okay.
Yeah.
I always thought that. I'm like, that's a pretty long walk, and you can't go back up the river. So,
Well, yeah, I'm thinking about doing a
we
rim
just
to
like
rim.
ditch you there,
Yeah.
let you figure it out.
You're shuttled, and I know other people have experience with this, but you're shuttled up to the canyon, and then you're at the end, you're shuttled back to. Most people start in Flagstaff, but I guess you can start different places.
Okay.
Yeah. So Deer Creek Falls looks like this. I like this picture because it gives a little better perspective. Without the people there, it doesn't look as big, but it's quite large. And doing something a little different today, rather than showing a video, which always comes through choppy anyway, we're going to do something a little more exciting, or equally exciting, or equally unexciting, depending on your perspective. I got a Google Earth image pulled up, and this is looking out toward the actual main gorge of the canyon. It's beautiful there. I know it's choppy. You're not seeing a smooth image or anything, but we're looking at the canyon, and then you scroll around, you turn your head a bit, and looky there. It'll catch up eventually. My internet's a bit slow here. But there you go. You got your Deer Creek Falls just right by the main Colorado River channel. So there you go. Fun times. Highly encourage you guys explore around with that. But let's go back to some statistics, and we'll get through this somewhat quickly today. But this is what we're going to start with. We are looking at, congratulations. All right. My wife just got a new job, so good for her. All right. I just need her to make way more money so I can retire early. So that's my goal. My brother was smart. He married a pediatrician. So, I mean,
that's how it works.
I know. Anyways, I guess we were talking about
through marriage.
What's that?
Get your money through marriage. That's
I know.
just a source of income.
I know. I'm doing it somewhat right. My wife is working her way up the corporate ladder, well, government ladder, but I need her to keep going because I need to be able to stop having to work. You know what's funny is I'm recording this class right now, so you could rewatch this conversation I'm having with you guys if you need to.
I wonder if she's listening through the door.
She very well could be.
It's a good thing to record. It's words of wisdom.
So. Hey, instead of talking about statistics today, let's talk about how you can get away with not doing any work in life. Okay. So, anyways, I guess we were talking about statistics. These are some recent polls. This is real data. I don't have the sources cited here, but if you go to Real Clear Politics, that's where I got this from. You can find all that fun stuff. These are the most recent polls for the upcoming election just for Arizona. And the question is, what are these polls trying to do? When someone creates a poll, what is it they're trying to do?
Get like a summary of people's opinions.
Yeah. Any other, and that is definitely a part of it.
Find the outcome of an event.
Yeah, I think you're kind of getting right to the heart of it there. And I mean, we don't need to, or any other thoughts on this? Okay. I mean, yeah, I think that was Maggie, you said that. You were kind of really getting close to what I was trying to see as an answer. And what there is there is a true portion of people who are, interested in voting for Trump or Biden, right? So the proportion of Arizonans who are going to vote for Biden or Trump, there's a real number out there. We don't know it. We won't know it until the election. But right now, all these pollsters are trying to estimate what that is. And, if they have good methodology, they're really trying to be as objective to get a true picture to see, oh, we think, with this particular pollster right here thinks 51%, not thinks, but their data suggests that 51% of Arizonans are going to vote for Biden versus 45% for Trump. Now, right here gets a little tighter. This one says 50 versus 47. Right here, they show 44 versus 48. And of course, these are point estimates because there is a true population parameter that exists. We don't know it, and we are just estimating it. Okay, so we don't need to go on that point too much longer, but we're gonna now consider this. Pollsters, when you look at this, and if you look in polls and things like this, especially I got this straight from Real Clear Politics again, pollsters always include a margin of error since they know, of course, they think they're capturing the true population proportion, but they know they probably aren't getting exactly right. So they include a margin of error. The first one that was there didn't include their margin of error, but you can see what the other ones are like. So it probably falls in the same range, more or less. So you can see 4.1, 4.4, and so on. So the question here is, what does this margin of error mean in relation to this poll?
Is it like how inaccurate the points could be, like the polls could be?
That's a fair way of thinking about it. Yeah. So of course, let's go with the second one because this one actually has a margin of error. They got 50%. Is it going to be exactly 50% voting for Biden? Maybe, maybe not. But when they show a margin of error of 4.1, they're pretty darn confident that it's not going to be like 60% instead. They're pretty sure it's going to fall within 4.1% above or below. And we'll talk about what that means as far as pretty sure. And that'll be part of our conceptual discussion today. Again, we're not going to do any calculations with it. So, and this is probably obvious. I hope it's obvious to you guys, but we're going to just go through it. And we'll just look at this one. We'll go with Trump's number right here and a margin of error 4.1. So if you add 4.1 to that, you get 51.1. 51.1 wouldn't be unexpected as the true population parameter, the true population proportion. It also wouldn't be unexpected, according to this poll, if it was 42.9% that voted for Trump. So they're pretty sure it's going to fall in this range, somewhere between 42.9 and 51.1. Their actual point estimate is right here, 47, but is that where it's going to land? They're not saying that definitively. So yeah, confidence interval is really this right here. So do you think that for all of these right here, we could create all these confidence intervals right here? Do you think that the true population proportion is going to be captured by all of them?
Can you repeat that one more time?
Yeah, and I was thinking I was gonna phrase it a different way. So the true number of people who will eventually vote for Trump, do you think these intervals that are being created, do you think all of them are going to capture it? Or is it possible, this is the next question, is it possible that the true population proportion falls outside of some of these margin of error? Like this
I
one
think
right
it's
here.
possible that it falls outside.
Okay. And yeah, that is a fair answer here. And that, of course, that kind of gets to, this is 39.6. I'm not going to do all these, but right here, they're saying that it might go from 39.6 to 48.4. So one key thing maybe to bring up right now is that we don't know the true population proportion right now. And we don't know what the population standard deviation, well, there's, we don't know what that would be, though that doesn't quite come into play, a standard deviation, because it's just one result. But anyways, we don't know the population parameter. So when we create this, we can only come up with a confidence interval based on the proportion that we got from our survey. All right, so that's going to be one difference as we move forward. And I'll make sure that point gets brought up a lot more. But you can see there's some overlap here, 42.9 to 51.1, 39.6 to 48.4. So there's some overlap between 42.9 and 48.4. If we create it for all of these, we can see there's going to be some overlap. All right. So it's these confidence intervals that kind of help us realize where the likely outcomes are going to land. Okay. Again, margin of error, hopefully pretty straightforward. But one thing to point out right now is that your margin of error is going to be the same above and below your point estimate. So it's 4.1 above this and 4.1 below 47. Okay, so now we're going to kind of look at it at a different level. Suppose I told you a new poll suggested that the proportion of Arizonans who will vote for Biden will fall somewhere between 44.8% and 53.2%. So now the question is, what is the point estimate for this poll? They don't tell us that. They just gave us an interval between these two numbers. So what can I do to find the point estimate?
Find the difference between 53.2 and 44.8, and then divide that difference in half, and then add that to 44.8.
All right. Yeah, we can do that. So now you're doing it in a slightly different way than what I'd say, but you have a correct calculation. And actually, the key thing about this is that there's not a, I'm going to show you a formula in a minute, but it's not really a formula that I expect you guys to write down and memorize. So Andrew, what you just said is a totally acceptable way of doing this. So we can do that. I'll just do it that way. So 0.532 minus 0.448 divided by 2. So anyways, that's 0.042. Okay, so this is what we can now add to this number right here, or subtract away from this one. But yeah, 0.448 plus 0.042 equals, that's going to be 0.49. All right, my point estimate is right here. Now, another thing we could have done, and this is something we'll see in a second, is you could just average these two. So you could just add them together and divide by 2. So I could have done 0.448 plus 0.532 divided by 2. You get the same number either way. But I'm not saying that this is the preferred way right here. Whatever way you can reason and logic your way through it is fine. And that's the key takeaway for this. Now, the margin of error for the poll, looks like we actually already calculated that, because with this calculation right here, and I'm just going to throw this in, I'm sure you could explain it, Andrew, but this margin of error, we basically took the margin of error, which is that value right there, and added it to the lower end of our confidence interval, and that gave us our point estimate. Okay, we could have subtracted it from the high end, but the essential calculation is this one right here. So we're going to summarize this in a second. Again, these are not formulas that I'm telling you you need to memorize these formulas or at all, because it's just not important in that way. Okay, so the interval 0.448 to 0.532 is the confidence interval for this point estimate of the population proportion, which is a lot of statistics language to say that basically this is the range of values we would expect for where the true value is. Okay, so let's look at this. And these are kind of the two formulas. So if you have any interval from A to B, we could get a point estimate by getting the average. We could get the margin of error by getting the difference and dividing that by 2. And just to summarize this, these are not on the formula sheet. They don't need to be memorized, but you should be able to approach this kind of problem and using your mathematical knowledge, work your way through it. Okay, so if that is still something confusing, we can stick around and talk about that a little more. Your homework tonight will have a little bit of this in it. Okay, now before we talk about confidence intervals in more detail, let's talk about confidence levels. Okay, so when we talk about confidence, what does that mean exactly? So it's typically, or it's always given as percent, your confidence level, and typically we'll work with the 90, 95, or 99% confidence levels, though you can use any confidence level you want. I've seen 80% confidence intervals. I've seen 99.9% confidence intervals. I've seen like even weird ones like 91% confidence intervals, but it tends to be one of these three, especially the 95%. Okay. So again, we're not going to get into the nitty gritty of the calculations today, but it does kind of suffice for today to say that the larger your confidence intervals are, the larger your confidence levels are, the larger your confidence intervals are. Now that's jumping ahead a little bit, and we're going to go to this real quick, and we're going to run through some things. All right. So here's our population distribution. Here's a sampling distribution. So we have a sample size of 20. Notice, and this is just a reminder from stuff in the past, if I change my sample size to 50, notice what happens to the sampling distribution. It looks like our population distribution changed, but really it was just shrinking down so we can make room for the higher peak in our sampling distribution. And notice the width of our sampling distribution as I go up higher. So the width of our normal distribution, population one, isn't changing, but based on our sample size, our sampling distribution is. So I'll go back to 20 where we started at. That's a good starting spot. And I've got confidence intervals right here. Notice that this doesn't change anything right now. I can slide that up and down and it's not changing our graph, our display. So I'm going to draw a sample. And what we had here was we picked 20 people from this population, a random sample, and there was a calculation done at the 95% confidence level. Again, we're not doing that calculation today, but our calculation depends on the confidence level that we choose, and we'll learn more about that. So this was a calculation done, and what we have is the point estimate, which is the dot. The lines coming off to the side represents the actual interval, our kind of range of uncertainty. And it just so happens that this green line is the true population proportion, or mean in this case. The true population mean is right here. We got the sample, and we happen to capture it just barely inside of our confidence interval. If I did another sample, well, this one lands almost perfectly on it. And this is randomly generated each time, so I don't know what the next one's going to be, but we got a lot of samples drawn, and our sample mean happened to be right here, with the confidence interval going around it. All right, I'll just do a few more of these, and I'm going to go until we find one that doesn't capture the population mean. There we go. So notice what's happening here. For all of these, the confidence interval happened to cross this green line, which is a way of showing that it did capture the true population mean. But in this one, we had a point estimate. We had this level of uncertainty coming out. And even with that, the true population proportion mean was outside of the confidence interval. That can happen. How often do you think that's going to happen?
5% of the time.
You got it. 5% of the time. So now what I'm going to do is I'm going to keep everything the same, but I'm going to do the sample of 25. I'm going to do this many, many times until I get over 1,000. So you'll notice right here, our total keeps going up. So I'm going to get that over to over 1,000. Okay, there I got over 1,000. I'm going to do it one more just so we can see. There we go. A few that miss. So we've got most of these are capturing the true population mean. Some of them are not. Out of our total of 1,038, 991 of them captured the true population mean, and the remainder there, whatever that is, 40, I can't do math, 45? Yeah, 40, no, that's more, 47 of these, there we go. 47 of these did not capture the true population mean. So we had 96% of these successfully capture the true population mean. So there we go. That's kind of the way that we interpret confidence intervals. It's not so much that, and we'll talk about this more, it's not that there's a 95% chance that we got it right. It's that if we had many, many, many confidence intervals, 95% of them would capture the true mean. Okay, so we're going to change things a little bit, and I want you to pay attention to the width of our confidence interval. What I'm going to do is I'm going to change our confidence level. And I'm just going to slide this down to 80%. We're now working at the 80% confidence level, and this is a nice thing. It actually keeps track of all of the previous confidence intervals from before. We can only see 25 of them right here, but there are 1,038 is keeping track of. And when we change our confidence level to the 80%, it looks like right at 80% of them captured the true mean. And we can see right here that 1, 2, 3, 4, 5, 6, 7 of these are not capturing it. So compare, and this is the key takeaway, because this is really dealing with conceptual stuff for today. Compare the confidence interval right here, and I'm going to slide this up to the 99.5% confidence level. Okay, and what happened as I changed the confidence level?
The thingies got wider.
Yeah, there you go. Our range, our confidence interval got wider. So, I mean, it's really obvious if I do it like this, you can see the changes happening. So lower confidence level means that I have a lower confidence, a smaller confidence interval. Higher confidence level means I have a wider confidence interval. So those are directly related. As one goes up, the other goes up. All right, and that kind of, hopefully that makes sense, because now keep in mind, we're trying to capture this 99.5% of the time, which means we want to give ourselves a little bit more leeway. Say, I'm going to widen my interval out a little bit, and that makes me more likely to capture it. All right, so if I sample 25 times, every one of those hit. I'm at the 99.5% level, so most of the time I should get this. So how many times does it take until I miss? So there's a third, fourth, fifth, sixth. Okay, it took me 150 times to get one that did not capture the true population mean. So we'll talk about this more, but having a wider confidence interval means we're more likely to capture it. But of course, there's less precision when we do that because it's a wider interval. All right, so that's confidence level. Let's now talk about sample size. And when I change this, it erases all of our work, but no worries. I'm going to go down to the biggest sample size, or sorry, the smallest sample size. And I'm just going to leave this at the 95% confidence level the whole time. All right, so sample size of 5, 95% confidence level. And we can see what's going on. I'll sample a few times. You can just see how wide that confidence interval is. Now I'm going to change this up to the biggest confidence level we can get, which is 250, the biggest in this app. Now I'm going to sample here. And what are we seeing?
The confidence range is short.
There you go. So we're going to see why this is, but this is going to tell you that there's an inverse relationship to the number in our sample size n and the width of our confidence interval. So when it's 5, we have a pretty wide confidence interval. When it's a big sample size, we have a very small confidence interval. And so we can kind of play with this. We now know that if I raise my confidence level right here, it's going to get wider, but still it's not very wide when you have a big sample size. I could lower the confidence level and that gets very, very small. So that's kind of the key takeaway here. You can see now at the very extreme what our confidence intervals look like here compared to a small sample size and a big confidence level, how wide they are there. Okay, so there are 2 factors we can change to make our confidence intervals wider or narrower. And that's going to be confidence level and sample size. All right, I don't remember if there's anything else I really need to talk about with this. But again, we're not doing the calculations on this today, but when we do it, it's not going to be something that you're not, prepared for. I'll just say that. It's going to be a pretty straightforward calculation. Okay, so we already talked about this, so this is just to summarize a little bit. It's tempting to think that a 95% confidence interval we create is 95% likely to contain the true population, but that's not how you should think of it, because your confidence interval either contains the true population proportion or it does not. There's no percent chance like, oh, it's a 95% chance. It's intuitive to think that way, but it either has it or it doesn't. So instead, the way to think about it is that if we created many infinite 95% confidence intervals, we would expect 95% of them to capture the true population proportion. Okay. So here we go. A 99% confidence interval means that we would expect 99% of confidence intervals for sample size n to contain the true mean. And just like we already saw, higher confidence means we need to hedge our bets and widen that interval, cast a wider net. So there's always a trade-off between precision and accuracy. So here's where we could get a 100% confidence interval. I can be 100% confident that Donald Trump is going to get somewhere between 0 and 100% of the vote. I am 100% confident in that. I hope you're 100% confident in that as well. While that is very, very confident, it is also useless because it is imprecise. There's, that doesn't really give us information. Now, on the flip side, we could create a 20% confidence interval that estimates his vote share somewhere between 48.8% and 49.2%. But as precise as this is, we're pretty close. It's going to be around 49%. I'm making this up, but that is so inaccurate. This 20% confidence interval is useless. Okay, only 20% of those confidence intervals would capture the true population proportion. So we can't really use it. There's this balance between, we want to have a high confidence level, but we also want to be able to be, precise, and we can't get too high of accuracy or else we lose our precision. So the balance point is somewhere in the 90s. And I will tell you 95% is where most confidence intervals are, how they're created. So that's kind of a nice balance. Okay, so this is kind of the takeaway on changing our confidence intervals. We can change the confidence level. As the confidence level goes up, the confidence interval increases in size. All right, so just to drive that point home, unnecessarily perhaps, if this is my point, and this is a confidence interval, this might represent the 0.90 confidence level, and this might be the 0.99 confidence level. So as the confidence level goes up, the confidence interval increases in size. You're going to see this confidence level, confidence interval. Make sure you know the difference between them. Any questions on the difference between those two? And this will make more sense when we're doing the calculation, but confidence level is always given in a percent. The sample size, as sample size goes up, the confidence interval decreases. So if I've got confidence interval here, then the smaller sample size is going to have a wider confidence interval. So this might be n equals 10, and this might be n equals 100. So this is an inverse relationship. As sample size goes up, the confidence interval decreases. All right, hopefully pretty clear. This in the presentation, I wanted this to be like a very clear takeaway page for you to refer back to. Okay, we've got an example here. A 95% confidence interval for a proportion of people who will vote for Trump is calculated from a random sample of 500 Arizonans. How is a confidence interval affected if you change it to a 99% confidence level?
The confidence interval will also go to 99.
Yes. And what does that mean in practice? How does that change the confidence interval?
Would it increase it?
Yeah, it would widen it. So you could think of it this way, that your margin of error increases. So if we started off in this one, let's say our margin of error was 4, and then we go to 99% confidence level, then we might have our margin of error go to I'll just say 4.5, which means our confidence interval right here will now widen just a little bit for the 99% level. The point estimate hasn't changed, but the range of values that we're confident it will fall in has changed. Okay, so how is this confidence interval affected if you polled 1,000 Arizonans instead?
Instead of like widening, does it like shrink?
That's right. So this is where it's inversely related. So if you started off, I'll try and draw that same thing. This is my original margin of error with a 95% confidence level. Let's say both these have 0.95 confidence level. But with twice as many people in the survey, we might expect a margin of error to be reduced. Okay. Really important concept right here. It's important to understand how sample size and confidence level affect that. It's gonna make more sense tomorrow. In some sense, maybe I'm doing this a little out of order, but I just wanted to spend the day going conceptually over things, and tomorrow is gonna be the calculation day. So conceptually, confidence level is directly related to the confidence interval, and sample size is inversely related. Okay. And this right here helps explain it just a little bit. So we've got two things, and maybe this is even backwards a little bit. This is what you're going to find in your AP formula sheet, and we're going to see how this is a useful thing to know. But you got your statistic plus or minus critical value, which is going to be something tomorrow, times the standard error. Again, we'll get into that tomorrow. This is not as complicated as it might seem. It's going to be very similar stuff that you're very familiar with, just different names for it. So really we're saying the point estimate plus or minus the margin of error. So this margin of error is affected here by those two things, the critical value and the standard error statistic. And I'll go ahead and tell you right here, This is related to your confidence level, and this is related to your sample size. Okay, so that's why it changes. All right, maybe that's enough on that for now. I think we have one example, and then that's it for today. Okay, so a marketing research department for a candy company creates a 90% confidence interval for the proportion of candy shoppers that will buy a new flavor of candy instead of a competitor's candy from a sample size of 435 people. So all the information we need is in there right now. They found that between 8.4% and 17.3% of customers will prefer the new flavor. So there's the confidence interval. And it's a 90% confidence interval. So how are we going to interpret this? All right, so let me just kind of highlight this. We got 90% confidence level. We got our actual confidence interval right here. Here's my context, proportion of shoppers that will buy a new flavor of candy instead of a competitor's candy. All right, so here's the interpretation. I'm not asking you to share this right now. This is kind of a template, and I will make sure that we see this quite a few times. But here's how we would say it. We are 90% confident that the interval from 8.4% to 17.3% captures the true proportion of candy shoppers that will buy the new flavor of candy instead of a competitor's candy. Okay, and this is an appropriate interpretation of this. So in your homework tonight, there's not a lot, but you're going to have an opportunity to read a scenario, come up with your own interpretation, and you can refer back to this presentation to make sure you understand maybe what the format should look like. And anyways, that's it for today. I just wanted to point out, make sure you read chapter 19. That covers what we're talking about today and tomorrow. We're going to do chapter 23, part of chapter 23 on Friday and Monday. And so we'll get to that. There is a worksheet on the Canvas classroom, and I include the answer key. I do ask you to submit one of the problems like usual, but I wanted the answer key to be there so that you could kind of check your work tonight, because this is very kind of conceptual stuff. It's important you get this down. So any questions that come up on this worksheet, please be prepared to ask those questions tomorrow to get that understanding. The calculations follow the conceptual understanding. So if you can understand this stuff today, tomorrow won't be that bad. All right, but as far as it goes, that's all I've got for you today. If you don't have any questions, you are free to go, but have a wonderful day and I'll see you tomorrow.